Okay,
Okay.
so welcome everybody to our latest webinar. And today we've got Alex Aldea from Romania, and he's going to be doing a webinar presentation on the challenges of establishing the water balance. Now, Alex is going to go through the Excel spreadsheet as well. So it's a bit more technical, this webinar. So if anybody wants to ask questions during the webinar rather than waiting to the end, I can keep an eye on the chat. And then if there's anything that I think we should answer straight away, I'll butt in, Alex, if that's okay.
Okay, but I'm pretty sure there will be some. I will pause, probably. I will pause at some point and ask for the questions. Well,
okay.
so
I'll hand it over to you then.
Thank you. Well, hello everybody. I mean, good morning, good afternoon, good evening. It seems to be very appropriate this day. I understand there are probably people from all over the world. So this webinar is actually, I did this webinar in order to help some other people that are starting to do the water balance, or they are trying to know the terminology and the basics of the water balance. It's mainly done from my own experience and other people's experience, of course. So it's challenging for establishing the water balance. And I will start right away. And I would like you to recommend some books. There are plenty other books available and documentation. However, you could start with, with the IWA performance indicator for water supply service. Now, I think this is the picture for the second edition, but the third edition is already out. And another document, very good and very technical document, is the EU reference document for good practice on leakage management. It's this EU document. It's available free. Of course, there are many other documentation like this. You know, there is M36 from American Water Association and so on. As a software, I will do a little example using the Water Balance EasyCalc. It's a program that is also free. It's made by Roland Limberg, and it's available at his website. It's an Excel spreadsheet, and you know, it's available in several languages. If some of you don't find your language here, no problem. You can add your translations, send it to Roland, and you will have then the software also in your language. That being said, let me start with the next slide, which is the water balance. IWA water balance is the simple format. I'm going to use this format. I'm not going to use the format that we have separately imported and exported water. So basically, I'm going to do a very quick explanation for what you see on the screen. So first of all, if you didn't heard about it, or you didn't actually calculate the IWA water balance before, chances are that you already have something like the system input volume. You know what water comes into your system, and then you have the last column, revenue, which is revenue water and non-revenue water. And of course, many people have different interpretations if you only have the first and the last column. So the IWA introduced all this column in between that will explain better every component. So the idea is that basically what you call by non-revenue water is not made only of water losses. It has three major components: the real losses, the apparent losses, and the unbilled authorized consumption. Okay, and basically that means that you know, unbilled meter consumption, it's usually one of good example are, let's say, technological consumption in the water treatment plant. Now the IWA water balance doesn't have a component that will say technological consumption. You won't find this. But if, for example, you meter your consumption, that it will go on the unbilled meter consumption. And if it's estimated by, doesn't matter by what method, it will go under unbilled unmetered consumption. Of course, there are other types of authorized consumption. Usually you go the firefighting volumes necessary for the firefighting squad. Basically, they are also unbilled, but also unmetered. So you'll find here, and various other consumptions. Now, the apparent losses will have two major components: unauthorized consumption, that means water theft, that means unaccepted use of fire hydrants and so on, meter bypass, stuff like that. And the other are meter errors and data handling. Now the real losses component are dealing with, you'll find here leakages in your water distribution network. You'll find leakages, if any, at the reservoir and so on. So the only component with the revenue water is actually made by billed meter consumption and billed unmetered consumption. Basically, this is what you'll find reading any material on the IWA water balance, very short. How you calculate such water balance, you will find it that it's quite easy. There is a step-by-step process. So I will very briefly describe it. So step one, you have to determine the system input volume. Okay, you have to, this is the data that you have to introduce in the water balance. Step two, you have to determine the authorized consumption, and you determine that by entering all the information in the fourth column here. So you have to enter billed meter, billed unmeter, unbilled meter, and so on. Then you add those two, and you have the figures in this third column, and then you add also those two, and you have the authorized consumption. The third step is you have to estimate the apparent losses. So you will have some data for unauthorized consumption, meter error, you add those two, and you have the apparent losses. So now you have billed authorized consumption, unbilled authorized, and apparent losses. So the fourth step is actually to calculate the real losses. This is called actually the top-down approach. You subtract everything, you subtract these figures here from the SINSTAR input volume, and you have the real losses. Of course, in some books, you will find a fifth step. That is something that you have to estimate the real loss component. This is something quite difficult to do, especially if you are at the beginning. So I'm not going to insist on this anymore. However, when you see something like that, now there are some plausible possible reaction that people get. And usually you'll find that at a webinar like this, at a seminar like for 2 or 3 days, and someone will came there and present the water balance, explain all the components, the terminology, and then they will present this top-down approach. Basically, you have to put some figures there, and in a matter of like minutes, you will have the water balance. However, what I find out that people react first time to this thing. A first possible and plausible reaction is, this is something trivial. All you need is basic arithmetic. You don't need nothing more. I don't know why it's such a big deal. The second one, in the academia, it's even worse. They said, look, we are dealing with things like, you know, fluid mechanics, we are dealing with advanced algorithm. This is hardly something that we wanted to teach our students. They will learn something like that in like a 10 minutes video on the YouTube or internet. And then there is, on the other hand, people say, okay, it's about one table with some data. Why do you need a conference, webinar just for this? And so on, the list can go on. And I know that these things are true because I used to believe some of them years back. So I will start with a little advice. And this is something that someone else told me. It was Ian Meggs a few years back, and he heard it from someone else. And this saying in this community of water law specialists is not rocket science, but you can very easily get it wrong. And this is very true. So now I'm going to reach out to the person that are starting to do the water balance, but they may have one of the reactions that I explained earlier. You're probably a young consultant, you're probably someone in your water utility, and all of a sudden you have to do the water balance. And at some point you'll find that it's very easy. You will change your opinion soon enough. So let's start with the system input volume, with the first one. But the first question is, what exactly is a system? And here starts all the problem. How do you define as a system? Who defines what a system is? And let's take a very simple example. You know, we have some wells here, raw water, we have a pipe that goes to a water treatment plant, then goes to a reservoir, and then to water distribution network. So what exactly the system represents? And you will find out that different entities have different opinions. You have regulation agency that prefer a certain definition for a system. You have water utilities that in some cases they prefer another definition, and so on. For example, one thing that one possible situation is like this. Now, the regulation agency, when they're talking about a system, they think, or they like to think, they understand that the system starts here. And it's normal because this is should be a meter here, and then the water, and this is the point when where the water will be built. However, let's say in the water utility, the production department, they will understand better the system input. For example, the entry in the water treatment plant, because of course they need to know that, because they need to know how much water enter, how much then they can produce, and what are the technological consumption. However, the utility network maintenance, they will think, they will understand by system, most likely, the entry point in the distribution network, because that is their main concern. So let's say that you are at your utility and you find all of this, and you say, okay, you know what? I'm going to do 3 water balance. I'm going to do a water balance for each and every one of the situation. Is no big deal. All I need to know is what is the volume, the system input volume in those 3 situations. Now you might find out that there are no 3 flow meters or 3 meters for each situation. There is probably only 1, and that meters might be just here. And this is not going to help you in neither these 3 situations. So the advice, of course, there are many other possibilities. The advice that I give everyone in this case is start when you start with the water balance. Define your system where you have the most reliable data. then you can work your way out upstream or downstream much more easily. But define the system, and this is a very crucial step, because if you don't define your system, if you don't have a schematics of your network, then the chances are that every other component in the water balance, you will get it wrong, and you will get data from different departments, and everybody thinks different about what the system means. Okay, but since this is a simple example, I will show you some example that it happens to me some years back when I didn't have a very small network, but I have a water supply system, or what is called the water supply system. And let me show you schematics of how that system was. So we have something like this, and I will try to explain. In the blue, with the blue colors, you will see the main water utility branch. We have a bigger utility that had several branches. Okay, so the main utility branch was this in blue. They have a water treatment plant. They had the distribution in the network in the big city, but also they have another entry in the city from a third-party water supplier, and then this third-party water supplier have to supply the second city, and then in the third city, this one was supplied also from the second city and from somewhere else. Additionally, the bigger city exported water to another branch of the utility, and the project area actually was this area encapsulated in red. Believe it or not, this took several months for us also with the client to understand which data belongs to which city, to which company. It was very difficult, and until things got clarified when you have this kind of schematics. Unfortunately, this is a problem that you will find in many utilities, and they don't have a schematics. There is someone there that have the network in their heads. The problem that I found with this is that everybody has different things in their heads. So I will give you an example when I had a situation what was very difficult to understand the system. So the two people at the water company started to explaining, and they made drawings in the air for me to understand. So I asked them to put it on a paper, and until the moment that they started to put the network on the paper, they started also arguing with each other. Until that point, they didn't know that the other guy knew something else in his head about the water network. Okay, so this is a crucial step. Once you establish what is your system, how you define your system, regardless how, some other normative or standards or authorities will define it. Once you define exactly what is your system, you will have better numbers, the correct values in your water balance. Now, let's talk about the billed meter consumption. This is the second most important figure in the water balance, because this and the input system volume are the two numbers that you are going to build your water balance on. Now, with the billed meter consumption, you have to rely heavily on the billing records. There is no other way to do it. Okay, but make sure of one thing, that the consumption period is the same as the analyzed period. In other words, make sure that the data, the volume that you read from the billing records correspond to the period for which you will make the water balance. In this respect, it's better to avoid, for start, monthly water balance, because I've seen in some cases when water utilities do this monthly water balance and they have negative figures. Why? Because they have a pretty decent or correct figure for the system input volume, but since they rely on manual reading, they have to send someone on the field to read the meters, or they estimate it and they make a reading, let's say, 3 to 6 months. They will have different values for and incorrect values for the bill consumption, and therefore they will have all of nonsense data. So if you don't have a smart technology for reading meters in, let's say, 1 day or 1 hour, don't try to do monthly water balances. It is a good thing at this point to split the data, if you can't, on consumer category. You will see that you might need it later. The bill unmetered consumption. Now, where you could go wrong here? Still, you are going to rely on the billing records. There is no other way. Make sure again that you have the same period. Now, the unbilled unmetered consumption, it's sometimes directly linked with the degree of, depends on how many consumers are unmeters. So if the percentage of non-meter consumers is quite high in your network, please make a priority to install water meters. And then you'll have a more accurate figure about what is considered consumption in your system. Okay? And try to identify domestic consumers, because actually the non-domestic or commercial consumer, in pretty much in most of the cases, they are metered, they are not unmeters. Why you are gonna do this for the domestic consumer is to compare, let's say, the per capita consumption with the per capita consumption for domestic consumer that are metered. And then you will see if your estimation for their bill, it's correct or not. Unbilled meter consumption. This is quite rare for the water company and should be very insignificant compared to the bill consumption. It's an authorized consumption, and it's like I said, it's quite rare, and usually the company, the water utilities, may have a very good data on it. But there is one problem with that. Since this is an unbilled, okay, people will tend to not take care of these consumers. Probably they are not, they don't do the index reading properly and so on. So chances are that the errors here, the meters error and the data handling error, must be higher. So if you can, you have to verify also separately. You have to verify this this type of consumers. So, and you have to treat it also like a bill consumption in terms of data accuracy. Now we reach a point when anyone that will start to make a water balance will have a problem, and that is when you get to unbilled unmetered consumption. And I call this the gray area of the water balance, because here a lot of things can happen and a lot of things can go wrong. First of all, be very skeptical if you find out unusual high figures for this one. This is the preferred way for people to hide some of the real losses, of most of the real losses. I had so many cases when I had the unbilled unmetered consumption was quite high, and almost always the explanation was, well, we have a high technological consumption, which I don't know why, because if you do the calculation, sometimes you, in order for that figure to make sense, that will mean that, I don't know, you have to wash the reservoir once a week or something like that, you know, you will have to wash the entire sewage network once a week or something like that for those figures to make sense. Another explanation is something like, okay, we have a lot of leakages and bursts, so we need to make an intervention, and therefore we had a higher consumption in this area in order to, you know, to flush the pipes. The problem is that when you compare, and this has happened to me, you know, so many times, when you compare the burst record, when you compare the figure for the real losses, there are situations when the volume, you know, reported as the real losses is much smaller than the volume reported as unbilled meter consumption. So this is this is a component that requires special attention. Now, in order to have a better understanding or to better accuracy, it is a good way that if you have a consumption that could be metered, then it should be metered. Consumption like, no, technological consumption. And here you will need to have, no, a meter before the water treatment plant, a meter after the treatment plant. It will help everybody and also to understand what is the efficiency of the treatment plant and so on. So if there is a possibility to have this, to meter a consumption, to meter a consumer, sorry, then you will meter. I don't know if I will finish with this slide, and then I will pause for a little bit and see if there are any questions. Just a few minutes. Also, if you want to have an audit and you have to know where these figures for the unbilled meter consumption are, you have to examine the methodology used to estimate those numbers. Sometimes it's a good methodology, it's sound, but otherwise they are just pure guessing, and you can rely on them. However, be careful, because there are some situations where there is a valid explanation for some unusual high figures. For example, if in Romania we had a lot of, let's say, new networks, or networks that are a few years old, but then under some European project they were extended. So in order to do the works at some time, you know, the contractor used water for, you know, flushing or washing the newly installed pipe or something like that. They made a pressure test, and for a network that is correspond to a small locality, that those volumes were quite important. So in some cases, there is a valid explanation in 1 or 2 years possibly that they might have some high unbilled unmetered consumptions, for example. Now, you have to be very patient with this component. In my experience, you are not going to get it right for the first time. You need to build more data, because chances are, if you are starting to do the water balance at some point and nobody around you heard about the water balance, then nobody is used to these numbers. Nobody is used to the terminology, and everybody will give you the data that they have at that point. Remember, it takes a year to prepare the data for you to put in that table. And a year, someone, and by someone I mean like many people, have to work for an entire year only to prepare the data. So be patient. Start start at what point, see where the inconsistencies are, and then start building your data day by day. And after a year, you will have more accurate figures. So I finished with this slide, so I'm gonna pause for a little bit right now to see if there are any questions. No, if not, then I'll go. One question is what programs or softwares I recommend for starters, for beginners. I recommend the EasyCalc, the software that I'm just gonna use it a little bit. For advanced users, there are other software that they don't just do water balance, they do all sorts of analysis and help you in optimizing your network and so on. So just for the water balance, you could use the EasyCalc, or you can make your software in Excel, for example. Okay, so let's go. Oh, okay. Another question, but technological consumption. Yes, what do I mean by technological consumption? Okay, some people prefer to refer that as technological losses. So, for example, is the water that is needed in the technological process in the, let's say, water treatment plant in order to produce in order to make the water potable. For example, if let's say I have 1,000 cubic meter of raw water, I can produce 950 cubic meters, something like that. And the difference is considered to be technological consumption, something that is consumed in the technological process. Other part of technological consumption, at least in Romania, are the consumption or the when you have to use the water in order to flush the pipes after a pipe burst or something like that. Okay, I'm gonna go to the another component, an unauthorized consumption. Now here I saw some there are several approaches but by the water utilities when you are dealing with authorized consumption. And again, if you are new and you are just starting to do water balance in your water utility, chances are that you will find one of those three approaches. Now, the first approach that you will probably encounter is the so-called denial approach. That is, there is no unauthorized consumption. There is nobody stealing water in my network. There is no theft. There is nothing. And one possible variation of that is, okay, we didn't have any unauthorized consumption until you started to make the water balance. So, you know, probably there is a connection with that and things like that. I didn't heard of a water utility that don't have at least one consumer that will steal water. It is true that in most cases, the volume of unauthorized consumption, you know, the proven volume, is very small in comparison with, let's say, the real losses. And sometimes if you have an original operator, a very big operator with, you know, tens of little networks, it probably not be a good idea to insist on finding these fraudulent consumers. However, if you know that this kind of behavior is concentrated in one zone, in one area, then it will be more easy to identify those consumers and to take actions. Now, the second approach by the water utilities that I've heard is so-called the cautious approach. They don't say we have that people are stealing water, but we put a certain percent, usually from the authorized consumption, and we consider this as unauthorized. And this percent vary from company to company. Could be 1%, could be 2%, it could be 10%. And nobody knows who came up with these figures, actually. Most of the time, this problem you will have when people make, they will try to make a confusion. They confuse the authorized consumption with the meter errors because they are both in the apparent losses, okay? So they will actually, what they meant was not that the people are stealing water, but they have, you know, high meter error or something like that. In any case, you have to be very cautious with that. And then I found out another approach. And at first, it seems that it could be either the denial or the cautious approach. And I call this the overreacting approach. And that is, they don't report water losses at all, or a very small percentage, but the water company or the people that are convinced that the main problem with their network is that people are stealing water. And they are stealing so much water that, in fact, they do not have problem with the physical losses, but they have with the apparent losses. And usually the argument is, well, if we had so much physical losses, then all of the city will be flooded, or on the line of that. My advice to people on this subject is, look, surely I didn't find in Romania one case in, let's say, one regional operator that have huge apparent losses problems, not to mention unauthorized consumption. Most of the water losses are physical losses. So the overreacting approach doesn't sustain. In fact, none of the others approaches offers a very good solution, because no matter how you estimate the apparent losses using the top-down water balance, it will impact the real losses. Okay, so either you overestimate or underestimate this, your estimation will impact the value of the real losses. And you want to have a value of the real losses as realistically as possible. So here, this is very difficult to, if you are at the beginning, to try to find out, to hunt down who are the fraudulent consumers, how much water is lost due to theft or something like that. So one thing that you have to do is, first of all, cross-check your water balance, the resulting, let's say, the resulting real losses with some night flow measurements. Even if you don't have a flow meter installed, and unfortunately that's the case, even if you don't have SCADA, at least make every effort to have a 24-hour measurement, continuous measurement, and you will be surprised by the results. And then you can see actually how much real losses you have in your network and how much apparent losses, and act accordingly. I think, okay, I'll have to speed up a little bit. Okay, the meter errors. Of course, you have to conduct a survey at some point to see how exactly the the meter's errors are. But if you are at the beginning, if you are in doubt, I will suggest you to choose an error. Choose an error of the meter between 2 and 5 meters. And next year, I guarantee you that you have better data and this figure will be much accurate. Otherwise, if you want to make a survey, please pay attention to the age of the meters installed, the total values passed through the meters, and the installing position. Because some meters have to be installed vertically or horizontally, and if you install it in the wrong way, then you can have you can have an error up. I don't know, like I think it could go to 20%. And by the way, this is something that I knew at the beginning, then I forgot. Then some years ago, I spoke with Roland and remind me again. An error of 5% for 1,000 cubic meter is not like 50 cubic meters. And you will see that the Roland, let's hope I will have the time to make a very, very quick example or show you a already made example. You will see that in EasyCalc, the error, the volume corresponding to the error is calculated correctly. Now, and the final thing that you'll have are the real losses. But remember, you have so many unknowns, you have so many suppositions, okay, with the top-down measurements. So now it's a good idea to check all of those. And if you don't, at least make some night flow measurements. Very briefly, I will show you some cases that are quite interesting cases. And I will about night flow measurements. Now, there is a problem with that, and people tend to say, okay, you are not going to build your water balance, a yearly water balance, based solely on the 24-hour measurements. And that affirmation is correct. But that is not the point. That is not the goal of such measurements. The goal of such measurements is to verify what is the minimum night flow. And we made the assumption that real losses, the maximum real losses are the minimum night flow. And then we will check this estimation from measurement with the estimation in the water balance. And then we'll see how accurate were we. Please be careful with these measurements in the interpretation. It is important to see if there are seasonal variation in your system, and therefore you have to either you time your measurements, or you could apply a coefficient based on the period from which that measurement was made. Also, if you have a system where when you have network or localities when you have a lot of tourists, please understand that you could have a very high night flow that will very likely be a legitimate consumption, because you have nightlife. Yes, you have clubs and you have bars and restaurants and so on. So you have to be very careful with interpreting this information. However, I will show you some information, some measurements that reveal something quite dramatic. And just by looking at a snapshot of the network like this, you will see what you can find. First case, this is the flow that was supposed to be and was measured at the entrance of the network. Okay, so you very quickly you will see that there are some unusual pattern of this flow measurement. Even you see there are some negative flows. So the official explanation done by the water utility at first was okay, there is no problem. This is okay, this is the water hammer. I disagree a little bit. I said, okay, if this is the water hammer, then you have some problem in your network. Let's make another measurement. And after 5 minutes, I find out what it was. actually they had a bypass. Okay, so so water utility can have also a bypass from the and the meter was installed on that bypass. So this is how we have this pattern. Otherwise, the figures were for the water input system value were pretty much okay. Now this is a situation when they have a major intervention in the network. So this is a situation when you might want to repeat your measurements, okay? But even in this case, you can see here that, okay, at some point, the impact of the intervention it's gone, and you kind of see the pattern here. But in order to be sure, if you have this kind of situation, repeat the measurements. Okay, this is a situation when the water company said, okay, we have very low losses. And if I remember correctly, they speak in percentage, and I don't like to speak in percentage, by the way, but they have something like under 10%, and the ILI was like 1.1, something like that. Now you can see, and of course, when you look at this graph, actually, if I have the minimum night flow and let's say made an estimation multiplied by 360 years, I remember that I had a figure that was like 3 times, 4 times higher than what they said was entering in the network. So, when you have a case like this, okay, you will see very clearly what is the best, or let's say, what is the most accurate information. Okay, this one, let's see if you can spot the night flow. This is the night flow, and this little thing here, this little variation are actually the consumptions. It was a very was a case when I had an ILI like an 80. It was a very small network, and long story short, when they rehabilitated the entire, they built actually another network 10 times bigger than that, and they renounced this like 2 kilometers or something like that. But today, this is the biggest ILI that I could find in Romania, at least. Here is something very interesting. The idea was that only the blue curve was entering the network. It was from a pumping station, but that pumping station was supplied by a reservoir, and the reservoir was supplied by several wells. So we took measurement of the wells, and in one of them we found out this particular pattern here. And after some inquiry, we find out based on this one that that particular well didn't go into the reservoir, but direct into the network. So this is how we find out that you have raw water into the network. A little bit of detective work, if you will. So we said, okay, what entering your network is not is not only by this this curve, but you have to add also this one, because this is what your system input looks like. Anyways, thank you for attention. I think I am in time. If there are any questions. Okay, so I have some questions. Yes, I have some questions, and I will I will try to read them out loud. Okay, I have one question with that deal with will the recordings be shared with the participants? They will be uploaded on the YouTube channel, so you can see them there. I have another questions. What are the minimum correct data needed for a realistic water balance? Well, you have two key figures that you have to keep in mind. One is the system input volume, and this should be with an error of, let's say, less than 5%. And this should be very accurate. And the other one should be the bill consumption. Hopefully, you will have a situation where there is no billed unmetered consumption. So if you have those two figures, the system input volume and the billed meter consumption, you can work your way out for the other components. But if those two are not realistic, then you know the results are just guess. Okay, another question. Okay, this is another question with there is another question about the 5%. Yeah, this is a thing about the error. It's not when you say that meters have an error of 5 or 2%. It's not, and you calculate the meter error as a component from the water balance. You what you say is like this. Look, I have a meter, okay, that have some errors, and the errors are always in favor of the consumer. That is to say that if a meter has an error, then it's a loss for the water company. Therefore, if the meter has this error, that means that the water consumed, authorized and consumed by the user is something much higher. Okay, so we can calculate the percentage from that. I will, if you want, I can show you an Excel sheet. I don't know right now, but if you can email me, I can explain it. I can also show you how this is done. I have another question. It's if you have communicating meters, can this water be much simpler? Of course, if you have this thing, if you have everything, then the water balance, of course, can be much simpler. As I was dealing with the situation when this is not the case. Another. My country, okay, water for another question that said, in my country, water for schools and mosques are free. In which part of the table they should be entered? If we put them in the authorized unbilled consumption, NRW will increase. Therefore, it wouldn't be a good performance indication. Okay, that's a good question. Well, I don't care about the NRW, to be honest. Let's have an honest water balance. So yes, if they are free and they are authorized consumption, schools and mosques, okay, then you put them in the unbilled metered or unmetered. I will suggest in this kind of situation, even if the water is not no, they don't pay for the water, to have a meter on them connection. Then you will know that that water volume is not in the in the leakages or something else. The performance depends what you mean by performance, and by performance I think you go with the performance indicators. Well, of course NRW will increase, but that it's not the only performance indicator. If you want to find out if your network is performing good from a technical point of view, you can switch to other performance indicators. But there is a big debate about how to use, let's say, percentages and other indicators, but I think this is a subject for quite another webinar. Another comment said that production method typically are high-end electromagnetic, which have an error just 0.05%. Well, yes, it could be, but I have some comments about that. No, the meter is okay. If you will test the meter, you'll find out that it's fine. The problem is who does the installing. I have two of these situations in Romania with some bigger cities. When they had a night flow at some point about close to 0 liter per second. At first, they were very happy about it, and they said this is not possible because the water balance showed them otherwise. So they install ultrasonic flow meters, and what they found out is that the production meter didn't register correctly. Why? Because at the time of the installing, someone switch on an options that said if the velocity will go below a certain limit, then the meter will not register. And since in Romania we have quite big pipes, oversized pipes for the consumption that we now need, very often you will find that at peak demand we have like 0.3 meter per second, and this is very good velocity in most of the networks. So you imagine that at night you'll have a very low velocity, so the flow meter didn't register. So I have no problem with with what the technical specification of flow meter will say. What I want to check out, and I urge everyone to check out how exactly the meter is installed and so on, because there could be some problem regarding the errors. I have another one question here. The consumption for the consumers cannot be they cannot be done in the same day with the distribution index reading. How can we estimate more accurately the consumption? I suggest don't estimate. I suggest measure it. If you can measure it in the same day, at least at a period, you have to have a period for, let's say, 3 months, half a month, or maybe a year. Okay, so don't try to estimate the consumption. Read it very carefully. Usually the water balance is done in the months of March, something like that, when everyone, the financial department, everyone has all the reading and made all the necessary corrections. So don't estimate, just read it. From Ashok, how much do you assume as apparent error in meters at your country? Well, that depends. Usually what we found is like a 2% for a meter. It's a pretty good estimation. But then again, you have one figure, okay. Apparent error in meter, in domestic meters. Oh, okay. Between 2 and 5. If you don't have any study done in that particular area, you could go, I will say, 2% error for newly installed. Okay, and we'll go like, let's say 5% for the older ones. However, there is some law that will require you that for like, I don't know, once in 3 years, you have to take your meters and check it. And if possible, you have to replace the meters. So basically, I would say that no matter what, I could stay in this range of 2 and 5%. Okay. So Roland, hi Roland. Roland just made an announcement here. Yes, I will also attend that assignment performance indicators. It also be quite interesting. If there are any other questions, if you will want to send me other questions, you can you have my email, and you can no problem, you can write me an email if you want. Okay. So, Gary?
Yep. So thank you very much, Alex. And I think we will stop the session there. And as Roland has mentioned, the next one will be on Friday, and it looks like it will be an interesting one as well. So thank you very much, Alex.
Thank you. Thank you.